In the chaos of the Eastern Front, Soviet soldiers had learned to recognize a sound that meant death was coming. It wasn't the crack of rifle fire or the whistle of incoming artillery. It was something far more terrifying, a buzzsaw ripping through the air at 1,200 rounds per minute. They called it Hitler's zipper. The Americans called it Hitler's buzzsaw. To the British troops fighting across North Africa and Europe, it was simply known as the bone saw. But its official designation was MG42, and it was the most feared infantry weapon of the Second World War. What made this weapon so revolutionary wasn't just its devastating rate of fire. It was the fact that Nazi Germany had achieved something military planners thought impossible. They had created a machine gun that was cheaper, faster to produce, and more reliable than anything the Allies possessed, all while maintaining superior performance. In an era when military technology demanded precision machining and expensive manufacturing processes, German engineers had designed a weapon that could be stamped out of sheet metal in a fraction of the time and cost of its predecessors. The year was 1942. The German war machine was stretched across two massive fronts, bleeding resources and manpower at an unsustainable rate. Traditional manufacturing methods couldn't keep pace with battlefield losses. Germany desperately needed weapons that could be produced quickly, cheaply, and in vast numbers, without sacrificing the quality that had made German arms legendary. The MG42 was the answer to this existential crisis, and it would prove so effective that its influence would extend far beyond the battlefields of World War II. This wasn't just another weapon. The MG42 represented a fundamental shift in military thinking, combining industrial efficiency with devastating tactical effectiveness. While it cost roughly $100 to manufacture, equivalent to about $1,500 today, its impact on the battlefield was incalculable. A single MG42 team could pin down an entire company of soldiers, creating killing zones that were nearly impossible to cross. Its distinctive sound alone could break the morale of advancing troops. But the true genius of the MG42 lay not just in what it could do on the battlefield, but in how it was made. In factories across Germany, workers who had never built weapons before could assemble these machine guns using simple stamping and welding techniques. There were no complex forgings, no precision milling operations that required master craftsmen. The weapon was designed from the ground up for mass production, yet it performed better than guns that cost 10 times as much to build. As the war raged on, Allied intelligence officers began to realize they were facing something unprecedented. Captured MG42s were shipped back to testing facilities in Britain and America, where engineers tore them apart, studied every component, and asked themselves a troubling question: how had Germany created something so effective with so little? The answer would reshape infantry tactics, weapons design, and manufacturing philosophy for generations to come. Even today, more than 80 years after its introduction, variants and descendants of the MG42 remain in service with military forces around the world. This is the story of the machine gun that terrified a generation of soldiers, revolutionized weapons manufacturing, and became the most studied firearm in military history. The story of the MG42 begins not with triumph, but with frustration. In the late 1930s, the German military relied heavily on the MG34, a superbly engineered machine gun that represented the pinnacle of traditional weapons craftsmanship. The MG34 was accurate, reliable, and versatile, capable of serving as both a light machine gun with a bipod and a heavy machine gun on a tripod mount. German doctrine built entire infantry tactics around this weapon, with rifle squads designed to support and protect the machine gun team rather than the other way around. But the MG34 had a fatal flaw that became apparent as Germany prepared for large-scale warfare. It was extraordinarily expensive and time-consuming to produce. Each weapon required extensive precision machining, with components milled from solid steel blocks. Skilled machinists spent hours creating the intricate parts that made the MG34 function so smoothly. As German military planners calculated the weapons needed for the coming conflict, They realized that traditional manufacturing methods simply couldn't produce machine guns fast enough or cheaply enough to equip the massive army they were building. In 1937, the German High Command issued a challenge to the nation's arms manufacturers: create a machine gun that maintained the MG-34's performance while dramatically reducing production time and cost. The weapon needed to be just as reliable, just as deadly, but capable of being manufactured using modern mass production techniques. It seemed like an impossible task. How could you simplify a weapon without compromising its effectiveness? The Metal und Lackierwarenfabrik Johannes Grossfuss AG, a metalworking company in Dublin, accepted the challenge. Their chief designer, Dr. Werner Gruner, took a radical approach. Instead of trying to simplify the MG-34's design, he started from scratch, asking a fundamental question: what if we stopped thinking like gunsmiths and started thinking like industrial engineers? Gruner's team studied every component of a machine gun, questioning decades of manufacturing tradition. Did parts really need to be milled from solid steel, or could they be stamped from sheet metal? Did tolerances need to be so precise, or could simpler designs achieve the same reliability? Most controversially, could they increase the rate of fire beyond what anyone thought practical, knowing that the weapons wouldn't last as long but could be replaced quickly and cheaply? The answers led to revolutionary design choices. The MG-42's receiver, the heart of the weapon, would be made from two stamped sheet metal halves welded together. The barrel would use a simple locking system that allowed it to be changed in seconds without tools, addressing the heat buildup from rapid fire. Springs and simple pins replaced complex machine parts wherever possible. The weapon would use roller-delayed blowback, a mechanism that was both simpler and allowed for much higher rates of fire than the MG-34's rotating bolt. By 1942, the first production models began reaching frontline units. Soldiers who had trained extensively on the MG-34 approached the new weapon with skepticism. It looked cruder, felt lighter, and had visible welds where the MG-34 had seamless machining. Many questioned whether this stamped metal contraption could possibly match the performance of their beloved MG-34. Those doubts evaporated the first time they pressed the trigger. The MG-42 fired so fast that individual shots merged into a continuous roar. The rate of fire was so high that tracer rounds appeared to form a solid line of light stretching toward the target. Where the MG-34 fired at a respectable 800 to 900 rounds per minute, the MG-42 screamed at 1,200 to 1,500 rounds per minute. This wasn't just faster, it was a different category of weapon entirely. The tactical implications were immediately apparent. At that rate of fire, enemy soldiers couldn't time their movements between bursts. There was no rhythm to exploit, no pattern to anticipate. The MG-42 created a wall of lead that was effectively continuous. Suppressive fire became absolute suppression. Soldiers caught in the open had no choice but to freeze or die. But the weapon's true genius revealed itself in the factory. Where an MG-34 required 150 hours of machining time, an MG-42 could be completed in 75 hours. The cost dropped from 312 Reichsmarks to just 250. More importantly, the work could be distributed across multiple smaller facilities, reducing vulnerability to Allied bombing. Workers with minimal training could stamp, weld, and assemble components. As German industry came under increasing pressure from Allied air raids, the MG-42's simple manufacturing process became as valuable as its battlefield performance. German tactical doctrine evolved around the weapon's capabilities. Infantry squads were built around a single MG-42 team, with riflemen serving primarily to protect and support the machine gun. Officers were trained to think in terms of machine gun positions, with every tactical plan beginning with the question, where will the MG-42S be placed? As these weapons spread across German units fighting from the frozen wastes of the Eastern Front to the scorching deserts of North Africa, Allied soldiers began to understand they were facing something unprecedented. The psychological impact was as devastating as the physical casualties. The sound alone could stop advances before they began. The first time American troops encountered the MG-42 in significant numbers was during the North African Campaign of 1942 and 1943. Fresh soldiers, confident in their training and equipment, advanced across the desert toward German positions, expecting resistance comparable to what their instructors had described. Then the air filled with a sound unlike anything they had prepared for, a mechanical scream that seemed to rip through space itself. Private First Class Felix Branham, who survived the Tunisia campaign, later described his first encounter with the weapon. "We thought we were being hit by multiple machine guns. The fire was so intense, so continuous, that it seemed impossible for it to be coming from single positions. When we realized it was individual guns putting out that volume of fire, that's when the real fear set in." The tactical reality of facing an MG-42 position was brutal. Allied infantry tactics had been built around the assumption that machine guns fired in bursts, with gaps between them. Soldiers were trained to move during those gaps, advancing from cover to cover in a coordinated rush. But the MG-42's rate of fire eliminated those gaps. A trained gunner could sweep an entire zone in seconds, and the weapon's quick-change barrel system meant it could maintain that fire for extended periods. On the Eastern Front, Soviet forces faced the weapon in even more desperate circumstances. Their doctrine often relied on massed infantry assaults, overwhelming German positions through sheer numbers. The MG-42 turned these assaults into slaughter. German machine gun teams, properly positioned and supported, could break up attacks by entire battalions. Soviet soldiers learned to recognize the distinctive sound and developed a fatalistic attitude toward crossing ground covered by these weapons. A Soviet after-action report from the Battle of Kursk in 1943 noted that casualties increased by nearly 40% when troops advanced against positions defended by MG-42s compared to positions defended by older machine gun models. The report concluded that frontal assaults against prepared MG-42 positions were inadvisable unless absolutely necessary for strategic objectives. The weapon's effectiveness wasn't just about rate of fire. The MG-42 was remarkably accurate for a machine gun, with a fairly controllable recoil pattern despite its high cyclic rate. German gunners were trained to fire in brief bursts even with the weapon's rapid cycle, using the term Führerstoß, or fire bursts of 3 to 7 rounds. This discipline turned the MG-42 from a bullet hose into a precision instrument of suppression. The quick-change barrel system proved to be another revolutionary feature under combat conditions. As any machine gun fires, the barrel heats rapidly, affecting accuracy and eventually causing malfunctions or even damaging the weapon. Traditional machine guns required several minutes for a barrel change, using tools and careful procedures. The MG-42's barrel could be swapped in 3 to 5 seconds by an experienced gunner, requiring only the flip of a latch. Ammunition bearers carried spare barrels, and teams could maintain fire almost indefinitely by rotating barrels every few hundred rounds. During the Italian campaign, American forces attacking German defensive lines learned to prioritize identifying and neutralizing MG-42 positions above almost any other tactical objective. Artillery and mortar fire would be directed specifically at suspected machine gun nests. Infantry would call for smoke screens to obscure the gunner's line of sight. Tank commanders would expose themselves to return fire specifically to locate these weapons so they could be destroyed with main gun fire. British forces fighting through France after D-Day developed elaborate tactical procedures for dealing with MG-42 positions. Standard practice involved fixing the position with one element, while flanking forces attempted to maneuver around to hit the gun from the side or rear. Direct frontal assault was considered a last resort, likely to result in heavy casualties even if successful. The psychological warfare aspect of the MG-42 cannot be overstated. Veterans from all Allied nations consistently reported that the weapon's sound had a uniquely demoralizing effect. It wasn't just loud, It was an alien, mechanical shriek that seemed designed to trigger primal fear responses. Soldiers who had steeled themselves to face rifle fire and conventional machine guns found their courage tested in new ways when that distinctive buzzsaw roar cut through the air. German propaganda was well aware of this psychological dimension and exploited it. Radio broadcasts to Allied troops would reference the saw or the zipper, reminding enemy soldiers what awaited them. The weapon appeared in propaganda photographs and newsreels, its distinctive profile becoming synonymous with German military might. The weapon's versatility added to its battlefield dominance. With a bipod, it served as a squad automatic weapon, light enough to be moved quickly as tactical situations changed. On a tripod, it became a heavy machine gun capable of sustained fire at longer ranges. It could be mounted on vehicles, fortifications, even aircraft. This universal machine gun concept meant that every German soldier trained on the weapon, and any position could be reinforced with overwhelming firepower quickly. As the war progressed and Germany fell increasingly on the defensive, the MG42 became even more valuable. Outnumbered German forces could hold positions far longer than their numbers suggested because of the weapon's firepower multiplier effect. Allied planners learned to assume that any German defensive position would include multiple MG42s and to plan accordingly. By 1944, captured intelligence documents showed that Allied military researchers had reached a sobering conclusion: Germany had created a machine gun that was simply better than anything the Allies possessed, and it had done so while spending less money and using simpler manufacturing techniques. The question was no longer whether to copy it, but how quickly they could do so. As Allied forces pushed deeper into German-held territory in 1944 and 1945, intelligence teams followed closely behind combat units with a specific mission: capture intact MG42 machine guns and ship them back for analysis. What began as standard intelligence gathering evolved into an obsession. Engineers in Britain, America, and the Soviet Union tore apart these weapons, studied every component, tested them to destruction, and reached conclusions that challenged fundamental assumptions about weapons manufacturing. The Aberdeen Proving Ground in Maryland became home to extensive MG42 testing. American ordnance officers fired captured weapons until barrels glowed red, submerged them in mud and sand, and subjected them to abuse that would have destroyed most contemporary firearms. The results were disturbing. Despite its crude appearance and simple construction, the MG42 proved more reliable than the American M1919 Browning machine gun, which cost significantly more to produce and required skilled machinists to manufacture. British weapons researchers at the Royal Small Arms Factory in Enfield reached similar conclusions. A classified report from late 1944 stated plainly, "The German MG42 represents a paradigm shift in weapons design philosophy. It achieves superior performance through radical simplification rather than increased complexity. Our current manufacturing doctrine appears to be fundamentally flawed." The Soviet Union, producing massive quantities of weapons under desperate wartime conditions, was particularly interested in the MG42's manufacturing techniques. Soviet factories were already using stamping and welding extensively, but the German weapon demonstrated levels of efficiency they hadn't achieved. Teams of engineers were assigned to study not just how the weapon worked, but how German factories produced it so quickly and cheaply. What these researchers discovered revolutionized their understanding of weapons design. The MG42 embodied principles that contradicted decades of manufacturing wisdom. Traditional gunsmithing emphasized tight tolerances, precise fitting, and individual craftsmanship. The MG42 used looser tolerances, relied on springs to compensate for part variations, and was designed so that components could be assembled by relatively unskilled workers. Yet it worked better. The roller-delayed blowback system was particularly elegant. Instead of complex locking lugs and rotating bolts, the MG42 used two simple rollers that wedged into recesses in the receiver, delaying the opening of the bolt until pressure dropped to safe levels. This system was lighter, simpler, required fewer parts, and allowed for the weapon's extraordinary rate of fire. It was simultaneously cruder and more sophisticated than what came before. The quick-change barrel mechanism represented another breakthrough in practical design. Previous machine guns treated the barrel as a semi-permanent component, difficult to remove and replace. The MG42's barrel was designed to be expendable, easily swapped without tools. This philosophical shift, treating certain components as readily replaceable rather than built to last, allowed for simpler construction throughout the weapon. As the war entered its final months, Allied forces began capturing German factories and documentation. What they found confirmed and expanded their understanding. The Germans had developed extensive manufacturing networks, with small workshops producing components that were assembled at central facilities. Quality control was maintained through functional testing rather than precise measurement. If a part worked, it was acceptable regardless of minor variations in dimension. Perhaps most impressively, the Germans had achieved this with a workforce that was increasingly depleted of skilled labor. By 1944, German factories relied heavily on forced labor, prisoners of war, and workers with minimal training. The MG42's design made this possible. The weapon had been engineered from the beginning to accommodate manufacturing by non-specialists. American attempts to copy the MG42 during the war failed. The T-24 machine gun, a direct copy, proved difficult to produce with American manufacturing methods. Factories accustomed to precision milling struggled with the stamping and welding techniques that the Germans had mastered. More fundamentally, American military bureaucracy couldn't accept that a crude-looking weapon could outperform traditionally crafted arms. The British had more success, developing the Bren gun to incorporate some MG42 principles, but a true equivalent wouldn't emerge until after the war. Soviet designers proved most willing to learn from the German weapon, and post-war Soviet machine guns would clearly show MG42 influence in both design and manufacturing philosophy. The final irony came in the war's last year. As German industry crumbled under Allied bombing and raw material shortages, MG42 production continued at significant levels precisely because the weapon could be made with limited resources and dispersed manufacturing. Meanwhile, Allied forces were discovering that their own sophisticated weapons were becoming harder to produce as supply chains stretched across continents. The weapon that cost less and required simpler manufacturing was proving more sustainable in total war conditions. By the time Germany surrendered in May 1945, the major Allied powers had each captured hundreds of MG42s and had formed teams specifically assigned to study German manufacturing techniques. The question was no longer whether the weapon represented superior design, but how to implement similar principles in their own arsenals. The machine gun that had terrorized Allied soldiers for 3 years was about to become the teacher for a generation of weapons designers. When the guns fell silent in Europe in May 1945, the MG42's story was far from over. In fact, it was just beginning its transformation from German weapon to global standard. The approximately 400,000 MG42s produced during the war became prizes for the victorious Allies, and the weapon's influence would reshape machine gun design worldwide for decades to come. The most immediate and literal continuation came in Germany itself. As the nation rebuilt under Allied occupation, the West German military was reconstituted in the 1950s as part of NATO. The new Bundeswehr faced the question: what machine gun would it use? After extensive evaluation of American, British, and other NATO weapons, they returned to a modified version of the MG42. Redesigned to fire the NATO standard 7.62 by 51 mm cartridge instead of the original 8 mm Mauser, the weapon was redesignated the MG3. The MG3 entered service in 1959 and remains in use today with the German military and armed forces in more than 30 countries. With only minor modifications from the original World War II design, this weapon has served continuously for over 80 years, an extraordinary testament to the soundness of the original engineering. The MG3 proved that the MG42 wasn't just effective in its historical context. It was a fundamentally superior design that could remain relevant across generations of warfare. The United States military, despite its wartime reluctance to embrace German design principles, eventually learned the lessons of the MG42. The M60 machine gun, adopted in 1957, incorporated the MG42's quick-change barrel system and showed clear influence in its operating mechanism. While not a direct copy, the M60 represented American designers finally accepting that the German approach to machine gun design had merit. Later American machine guns, including the M240 still in service today, continued to incorporate principles pioneered by the MG42. The Soviet Union and its successor state Russia showed perhaps the clearest debt to the German weapon. The PK machine gun, adopted in 1961 and still in widespread use, incorporated numerous design elements from the MG42, particularly in its feed mechanism and quick-change barrel system. Soviet manufacturing philosophy, already inclined toward mass production techniques, enthusiastically adopted the stamping and welding methods that made the MG42 so economical to produce. But the MG42's influence extended far beyond direct descendants. The weapon revolutionized how militaries thought about infantry firepower. The concept of the universal machine gun, a single weapon that could serve in both light and heavy roles, became standard doctrine worldwide. The idea that a squad's tactics should be built around supporting a machine gun rather than the machine gun supporting riflemen became accepted practice in most modern armies. Manufacturing philosophy underwent an equally profound transformation. The MG42 proved that stamped metal construction could equal or exceed the performance of traditionally machined weapons while dramatically reducing cost and production time. Post-war weapons design increasingly embraced these principles. From assault rifles to pistols, stamping became a standard manufacturing technique. The AK-47, arguably the most successful firearm design in history, owes much of its manufacturing philosophy to lessons learned from the MG42. The weapon's psychological impact left its mark on infantry tactics and training. Modern militaries train soldiers to recognize the importance of machine gun suppression and to respect the killing zone these weapons create. The lessons learned from facing the MG42, about the value of overwhelming firepower and the importance of tactical positioning for machine guns, remain fundamental to infantry doctrine. In the decades following World War II, the MG42 and its variants saw action in virtually every major conflict. It served in Korea, Vietnam, the Middle Eastern wars, and countless smaller conflicts. Each time, it proved effective, reliable, and deadly. Countries that couldn't afford to develop their own machine guns sought to purchase MG3s or manufacture them under license. The civilian collector market reflects the weapon's legendary status. Original World War II-era MG42s, when legally available, command premium prices. The weapon appears in museums worldwide as the definitive example of German engineering and the machine gun that changed warfare. Military historians consistently rank it among the most significant weapons of the 20th century, not just for its combat effectiveness but for its revolutionary design and manufacturing philosophy. Today, variants and direct descendants of the MG42 remain in active service with military forces on every continent. The basic design has proven adaptable to different calibers, different tactical roles, and different operational environments. From Arctic conditions to desert heat, from jungle warfare to urban combat, the fundamental principles embodied in that original 1942 design continue to prove their worth. The true measure of the MG42's significance lies not in the fear it inspired during World War II, though that fear was real and justified. It lies in the fact that more than 80 years after its introduction, military forces worldwide still can't design something significantly better for the same cost. The weapon that Germany created out of desperation, needing to produce effective firearms quickly and cheaply, turned out to be so well designed that it remains relevant in the 21st century. The machine gun that Allied soldiers called Hitler's Buzzsaw ultimately taught the world how to design, manufacture, and employ machine guns. It proved that simplicity could be sophisticated, that crude appearance could mask engineering excellence, and that wartime desperation could drive innovation that outlasted the conflict itself. Every modern machine gun, in some way, carries the influence of that distinctive weapon that once terrorized battlefields from Africa to Russia. The MG-42's legacy is written in the military doctrine of nations, the design principles of weapons manufacturers, and the continued service of its descendants in armies around the globe. It remains the machine gun that every nation studied, copied, and learned from. And in many cases, they never quite managed to build anything better.